Every overripe banana, orange peel, and apple core you discard contains nutrients your garden needs. Asian farmers never waste them. They ferment fruit scraps into liquid fertilizers using methods refined over centuries. No purchasing, no waste, just continuous cycling from fruit to fertilizer to food. Here's the system. Banana peel potassium extract. Banana peels contain 42% potassium by dry weight. That's higher than most commercial potassium fertilizers. Chop peels from 2 to 3 bananas and place in a quart jar. Fill with water and let sit for 3 days. The water turns brown as potassium leaches out. Strain and use directly on tomatoes, peppers, and flowering plants. For longer storage, ferment peels with equal weight brown sugar for 2 weeks. The resulting concentrate dilutes 1 to 500. Enzyme garbage. Liquid Southeast Asian farmers ferment fruit peels for 3 months, creating multi-purpose enzyme liquid. Mix 3 parts chopped fruit scraps to 1 part brown sugar to 10 parts water by weight. Use any fruit peels or overripe fruit. Orange, pineapple, mango, papaya all work. Combine in a large jar or bucket. Cover with breathable cloth secured by rubber band. Stir daily for the first week, then weekly after. Natural enzymes from fruit skins break down organic matter. After 3 months, strain and bottle. The liquid works as fertilizer diluted 1 to 500, cleaning agent at full strength, or compost accelerator. 1 batch from scraps you'd throw away serves multiple purposes for months. The fruity sour smell is pleasant compared to chemical fertilizers. Bokashi fruit fermentation. Bokashi handles all fruit waste, including citrus and overripe whole fruits that composting struggles with. Layer fruit scraps in a sealed bucket with bokashi bran containing effective microorganisms. Press down to remove air. Seal the lid. Drain liquid through the bucket spigot every 2 to 3 days. This bokashi tea dilutes 1 to 100 for immediate plant feeding. After 2 weeks, the fermented fruit scraps are pre-compost, ready to bury in garden soil where they break down in another 2 weeks. Unlike traditional composting that takes months and attracts fruit flies, bokashi ferments anaerobically in a sealed system. No pests, no smell beyond a sweet pickle-like fermentation. The process preserves 90% of nutrients compared to composting, which loses 40 to 60% through volatilization and leaching. Citrus vinegar fertilizer. Orange, lemon, and lime peels ferment into acidic fertilizer perfect for acid-loving plants. Chop citrus peels and mix with equal weight brown sugar. Pack in a jar leaving 2 inches of headspace. Cover with cloth. Ferment for 2 to 3 weeks until bubbling stops and liquid turns golden brown. Drain and bottle. The natural citric acid lowers soil pH while providing calcium, magnesium, and micronutrients. Dilute 1 to 1,000 for blueberries, azaleas, rhododendrons, and camellias. Apply monthly during the growing season. The acid also suppresses fungal diseases when used as foliar spray. Citrus peels are problematic in regular compost because oils inhibit decomposition and can harm beneficial organisms. Fermentation neutralizes those oils while extracting valuable nutrients and acids. Stone fruit ferment. Overripe peaches, plums, apricots, and nectarines become flowering stimulants through Japanese-style fermentation. Place whole overripe fruits in a jar. Add brown sugar at half the weight of fruit. The sugar pulls moisture from fruit through osmosis. Within days, liquid accumulates. Ferment for 2 to 4 weeks, shaking occasionally. Strain when fruit is completely broken down. The resulting liquid contains natural sugars that feed beneficial soil bacteria, plus organic acids that stimulate root growth and flowering. Dilute 1 to 500 and apply when plants begin setting flowers. The sugar-acid combination triggers increased bud formation and fruit set. Traditional Japanese farmers ferment yum plums this way, creating a tonic applied before flowering season. Western stone fruits work identically using the same principle. Papaya enzyme fertilizer. Overripe papayas contain papain enzymes that break down proteins and accelerate organic matter decomposition. Blend overripe papaya flesh with equal parts water. Add brown sugar at 10% of total weight. Ferment for 1 week. The papain remains active in the fermented liquid. Applied to soil, it breaks down organic matter, rapidly making nutrients plant available quickly. It also stimulates soil microbial activity. The microbes multiply in response to easily digestible organic compounds the papain creates. Use diluted 1 to 500 as soil drench monthly, especially effective when applied before planting to prepare beds. The enzyme activity helps decompose previous crop residues and activates dormant soil biology. Thai farmers traditionally ferment papaya for both culinary and agricultural uses. The same enzymes that tenderize meat in cooking break down tough organic matter in soil. One overripe papaya creates enough concentrate for 20 to 30 gallons of diluted fertilizer. Apple cider, vinegar, drench. Apple cores, peels, and bruised apples ferment into vinegar that prevents fungal diseases while adding micronutrients. Chop apple scraps and place in a jar. Cover with water. Add a tablespoon of brown sugar per quart. Cover with cloth. Natural yeast on apple skins begins fermentation within days. Bubbles appear as sugars convert to alcohol. After 2 weeks, alcohol-fermenting bacteria convert the alcohol to acetic acid. The liquid becomes increasingly sour. After 4 to 6 weeks, you have apple cider vinegar. Strain and bottle. Dilute 1 to 1,000 for soil drench around plants prone to fungal issues. The acetic acid creates slightly acidic conditions that suppress powdery mildew, black spot, and other fungal pathogens. Apply every 2 weeks during humid weather when fungal pressure is high. The vinegar also contains trace minerals from apples, including boron, calcium, and potassium. Commercial apple cider vinegar costs $8 to $12 per half gallon. You make it free from scraps while creating a dual-purpose product serving as both fertilizer and fungicide. Mixed fruit, FPJ, Korean. Natural farming's fermented plant juice works equally well with fruit scraps. Use any combination of fruit peels, cores, and overripe pieces. Chop everything into small pieces. Weigh the total. Add equal weight brown sugar. Mix thoroughly. The sugar draws moisture from fruit cells through osmotic pressure. Within hours, liquid begins pooling at the bottom. Pack the mixture in a jar, leaving 2 inches headspace. Cover with breathable cloth. Fermentation completes in 7 to 10 days when bubbling stops. Strain out solids and bottle the liquid. This concentrate stores for 6+ months in a cool, dark place. Dilute 1 to 500 for general-purpose fertilizer, 1 to 1,000 for young seedlings. The mixed fruit version provides balanced nutrition, since different fruits contribute different mineral profiles. Bananas add potassium. Citrus adds calcium and micronutrients. Stone fruits add sugars and acids. Tropical fruits add enzymes. The fermentation process makes all nutrients immediately plant available in liquid form that roots and leaves absorb within hours of application. Pineapple enzyme. Compost activator. Pineapple cores, peels, and crowns contain bromelain enzymes that accelerate composting dramatically. Chop pineapple waste into small pieces. Blend with equal parts water to create slurry. Pour this over fresh compost materials when starting a new pile or turn it into an existing pile. The bromelain breaks down proteins in the composting organic matter. This speeds decomposition by 50% or more. A compost pile that would take 4 months to finish breaks down in 2 months with pineapple enzyme addition. The enzyme also neutralizes odors. Compost piles smell when decomposition is anaerobic and incomplete. Bromelain accelerates aerobic breakdown, preventing the putrid smells from incomplete decomposition. For liquid fertilizer, ferment chopped pineapple waste with brown sugar using standard 1-to-1 ratio by weight. Ferment 2 weeks. The resulting liquid contains both nutrients and active bromelain. Dilute 1 to 500 for soil application. The enzyme continues working in the soil, breaking down organic matter and feeding microbial populations. Filipino farmers traditionally use pineapple waste this way. 1 pineapple creates enough enzyme concentrate to activate a cubic yard of compost or fertilize 100 square feet of garden beds. Mango seed, powder fertilizer. Mango pits contain seeds rich in nitrogen and slow-release nutrients. After eating the fruit, clean the fibrous material from the hard pit. Crack open the pit and remove the inner seed. Dry the seeds completely in the sun for 3 to 5 days until brittle. Grind dried seeds to powder using a coffee grinder or mortar and pestle dedicated to this purpose. The powder is slow-release nitrogen fertilizer. Mix into soil at planting time or side dress around established plants. The seed material breaks down over 4 to 6 weeks, releasing nitrogen gradually. This prevents the nitrogen burn that synthetic fertilizers cause while providing sustained feeding. One mango seed yields approximately 2 tablespoons of powder. That's enough to fertilize one tomato plant for the season, or amend 2 to 3 square feet of planting bed. Indian and Southeast Asian farmers have used mango seed powder for generations. The seeds also contain oils and compounds that may have antifungal properties, benefiting soil health beyond just nitrogen contribution. Collect seeds throughout mango season. Dry and store them. Grind as needed when planting. The powder remains viable for a year stored in airtight containers. This transforms a seed most people discard into valuable slow-release fertilizer that would cost $8 to $12 per pound if purchased commercially. Why fermentation beats synthetic fertilizers? Synthetic fertilizers are mineral salts derived from fossil fuels. They provide nitrogen, phosphorus, and potassium in chemical forms that plants can absorb immediately. This seems efficient but creates problems. The salts kill beneficial soil bacteria and fungi. Without living soil biology, plants become dependent on continued chemical feeding because the natural nutrient cycling system is dead. Synthetic fertilizers also acidify soil over time, requiring lime additions to correct pH. They leach easily into groundwater, causing pollution. The manufacturing process uses tremendous energy, contributing to climate change. And they're expensive. The average home gardener spends $120 annually on bags of synthetic fertilizer. Fermented fruit fertilizers work differently. They feed soil organisms, which then feed plants. This builds soil biology instead of destroying it. The nutrients are in organic forms that release, slowly preventing the leaching that synthetic fertilizers suffer. Fermentation preserves nutrients that composting loses. When you compost fruit, 40 to 60% of nitrogen volatilizes into the air as ammonia. Fermentation in sealed containers retains 90+% of nutrients in the liquid. The acids and enzymes produced during fermentation stimulate plant growth through mechanisms beyond simple NPK nutrition. They trigger hormonal responses that increase root development and disease resistance. Most importantly, fermented fruit fertilizers cost nearly nothing to produce. You're using waste that would otherwise go to landfill. The only input is brown sugar at $20 per year. Compare that to $120 for synthetic fertilizers. You save $100 annually while building soil health, that increases productivity over time. Synthetic fertilizers require increasing applications as soil degrades. Fermented organic inputs require decreasing applications as soil improves. The economics and ecology both favor fermentation overwhelmingly. Your first batch. Start this week with banana peel potassium extract. Save peels from 3 bananas. Chop them and place in a quart jar. Fill with water and let sit on the counter for 3 days. Strain and pour on your tomatoes or peppers. Notice how the plants respond within a week with darker green foliage and increased flowering. Next, collect mixed fruit scraps for 1 week in a container in your freezer. When you have 2 cups of scraps, chop them and mix with 2 cups of brown sugar by weight. Pack in a jar and cover with cloth. Check daily. Bubbles appear within 2 days. The fermentation smell develops from sweet to sour over 7 to 10 days. Strain when bubbling stops. You now have concentrated fertilizer. Dilute 1 part to 500 parts water. 1 cup of concentrate makes 50 gallons of fertilizer. Apply to your entire garden. Track which plants receive it and compare growth to unfertilized plants. The difference becomes obvious within 2 weeks. By month 2, establish a rotation. Dedicate 1 jar to banana peels for potassium, 1 jar of citrus peels for acid fertilizer, 1 jar of mixed fruit scraps for general feeding. Always have 1 batch fermenting while using the previous batch. This creates continuous supply without purchasing fertilizer. The cost reality synthetic fertilizers cost $120 annually. Fruit fermentation costs $20 for brown sugar. Over 5 years, that's $600 versus $100. You save $500 while improving soil instead of destroying it. That's wealth creation from waste.